this could be can be considered as a designate of the upper mantle. So this is a garnet websterite. So basically, this rock has three minerals in there. I mean, three major minerals. There is orthopyroxene, clinopyroxene, and garnet. So this is a very dense rock. I mean, rock type. So the most accepted theory about the formation of this rock is this forms when the continental crest actually matures and gets stabilized. So the water from the undergone, I mean, the subjected like continental crest get dehydrated, and the mantle actually get metamorphosed and form this rock. It's a very dense one. Mm-hmm. So this is actually a window to the upper mantle. So we rarely get this, very rare one, and also this is an Archean rock formed at around like 3 million years ago. Like,
so how did you find it? How and where?
We found it I found it during my PhD. Like I did surveying. I mean, field works. So during my field works, I accidentally found it in the field area.
Here in southern India.
In southern India, in the south of my study area during my PhD. So this is quite accidental, and it's not a usual rock type to find. So we found it in. So we have a major rock type in southern India called Charnakite. So we were in search of Charnakite, and accidentally we came across this rock type. So of course there's a story to connect between how the Charnakite forms after the continent gets stabilized, and so this actually designates or represents the lower part of the crest.
What does this stone tell us about the history of the Earth? What did you find out? How did you use it in your PhD?
Yeah, so this apparently tells you that the continental crust experienced high pressure temperature conditions at that time in the Archean. So we apparently dated this rock, so which yielded the oldest date of the silicon found from these samples are 3,000 million years. So like plus or minus like 20 million years. So it's like apparently 3,000 million years ago. And so this tells you that the continental crust at that time was, it has experienced high pressure temperature, more than 25 kilobar of pressure, and 1,100 degree centigrade at that time. So we can tell about how hot was the Earth, and the continental crust was actually matured thick enough. So in our science, like we tell that at the infant stage of the Earth had like microcontinents. It was thin and it's not matured. We had a thick oceanic crust, but not thick continental crust. But this tells you that this is part of the continental crust. This tells you that at that time the continental crust was matured enough. It had a thick, lower crust, which experienced such deep temperature pressure conditions.
Mm-hmm. So from which depth do you assume does
it should be at least found should have at least experienced at a burial of like 80 kilometers.
80?
Yeah, 80. 80. Yeah, so deep mantle, deep lower crustal rock. These are, yeah. Mm-hmm. So this is pretty dense, and you find the brown minerals in here are actually the garnets. But the green minerals in here are called clinopyroxenes. We can find with the cleavage, and this gives you the composition of the magma, which was actually original magma there. And this would have been a product of metamorphism. The garnets are. Okay, so texturally we have studied it, and also we have calculated the pressure temperature conditions. Mm-hmm. So that tells you that the garnets are later, and this is the clinopyroxene, which is really magnesium rich. So these are the characteristics of deep mantle magma, deep-seated magmas, mm-hmm. really high magnesium-rich magmas.
And can you describe or explain metamorphism? What that means?
Basically, metamorphism means like you get two components and you fuse together and you get a third component. So that's a metamorphism. And in this case, you have say this mineral, magnesium-rich magma, magnesium, silica, aluminum-rich magma with that composition, and you make that the magma or the rock, once it cools, it crystallizes and form minerals, and the agglomerate of minerals you form rocks. And the rocks, you the experience under high pressure temperature, it changes its form and chemistry. So it changes its chemistry, and it forms a new mineral, new phase. So that's why you get, this is a dominant phase, green one, it's clinopyroxene, but it forms a third phase called garnet. There's another mineral called orthopyroxene, which is not really abundant. But you form a third phase as the garnet, which is really rich in aluminum. Yeah.
How long does this process of amalgamation take or took?
Well, it's
A few hours?
No, it's millions of years. At least it should be 20 million years. That's what my study says. It's at least 20 million years. So this rock was apparently should have crystallized at 3,000 million years, and it again remelt at 2,550, and underwent again metamorphism at 2480 million years ago. So there are at least multiple metamorphic histories that this rock can tell you. Yeah.
And are you familiar with the term of the critical zone with that research field?
Pardon?
The critical zone, which is considered the thin layer around the Earth where life happens, where microorganisms live. That is considered as the critical zone.
Not really familiar. Okay.
So, do you see any kind of life forms connected to this kind of soil or sample?
Yeah, most of these rocks on which the research on which the microorganisms happens actually on the low-grade rocks, because there is a place, rock which we have any probability of finding life, because they are not experienced high temperature pressure. But these are high metamorphic rocks, which is apparently undergone more than 1,000 degrees Celsius. So we don't actually, expect any life preserved in here, because most of these, rocks where you expect 50 or 100 degrees Celsius, where actually you can find the fossils preserved. But here, in a highly metamorphosed rock, you don't actually see any life in here.
Okay.
Yeah.
So thank you very much.
Yeah.
Maybe you can send me your paper, your PhD,
Yeah, sure.
if possible.
Sure.
So we have got your knowledge about this rock. The rock is the central sample of your